Welcome to the Mushroom Kingdom. In this economy, Toad runs the local item shop, Princess Peach manages the royal treasury, and Mario makes his living fixing pipes. They all operate in very different markets, but they rely on exactly the same economic concept to survive: Price Elasticity of Demand, or PED. Toad needs to generate profit to keep his shop open. Peach needs tax revenue to repair the castle. Mario needs to secure a living wage. By applying PED to their specific situations, each of them can achieve those exact goals. To see how they do it, we start with the baseline equation. Total revenue equals price multiplied by quantity. According to the law of demand, these two variables move in opposite directions. If you raise your price, the quantity you sell will drop. Price elasticity of demand measures the exact responsiveness of that drop. It tells us which movement is mathematically larger. If you raise your price by 10%, PED calculates whether you lose 2% of your sales or 50%. This measurement doesn't create the reaction, but it allows us to quantify it. Understanding that sensitivity helps us predict who will prosper and who will struggle when prices inevitably shift. Let's apply this to firm pricing strategies at Toad's item shop. Toad sells two main items. Super mushrooms have plenty of substitutes, making their demand highly price elastic. One-up lives, on the other hand, are rare necessities, meaning their demand is highly price inelastic. This chart shows how elasticities dictate pricing. Look at graph B for the elastic super mushrooms. When Toad drops price from P to P1, quantity extends substantially to Q1. The massive surge in volume easily covers the small price cut, leading to higher total revenue. Now look at graph A for inelastic one-up lives. Toad takes the opposite approach. He raises the price from P to P1. Because buyers desperately need this item, quantity barely contracts. The higher price inflates his total revenue. We see similar mechanics in Princess Peach's treasury, but her motives are different. She has a dual mandate: raise money for repairs and discourage minions from buying dangerous bob-ombs. To raise money, Peach places a tax on warp pipes. Because they're an inelastic necessity, the tax shifts the supply curve left, but quantity demanded barely drops. The government captures massive tax revenue without destroying the market. For bob-ombs, demand is highly elastic. The same leftward supply shift yields a tiny tax revenue box, but triggers a massive quantity drop. She doesn't raise much money, but the policy successfully changes behavior. Firms have various strategic goals, but often rely on PED to guide immediate revenue decisions. Governments use the same metric to determine if a tax primarily raises funds or alters choices. This brings us to Mario and the labor market. A worker's wage depends entirely on derived demand, meaning demand for Mario's labor is derived directly from demand for the plumbing services he provides. When a pipe bursts, emergency plumbing becomes a highly inelastic service. Because of this, Mario can negotiate higher wages. The mayor accepts higher costs because they can be passed to consumers through higher plumbing fees. Let's test this logic. Bowser starts selling spiny shells, which have highly elastic demand due to cheap knockoffs. If Peach levies a heavy tax on them, what happens to Bowser's revenue and Peach's tax yield? Because the demand is elastic, Bowser's revenue plummets and Peach collects very little tax. Getting the answer right is a good start. But on an exam, you must articulate these chain reactions clearly. We do this using the STAR method. First, state the PED. Second, trace the shift in price and quantity. Third, analyze the specific impact on revenue, taxes, or wages. And fourth, provide real-world context to ground your answer. Memorizing economic theory won't get you full marks if you can't structure your response. This four-step framework is how you prove your understanding to an examiner under time pressure. Let's apply STAR to a capstone exam prompt. Evaluate the effect of a 10% tax on a highly inelastic primary commodity. Looking at this chart, we will focus exclusively on the steep red demand curve to represent the commodity. We execute the S and T steps first. State that the commodity is highly inelastic. Then trace the shift. A 10% tax causes a large vertical price increase, but as we can see by the narrow horizontal gap, it results in only a fractional drop in quantity demanded. Next, we move to A and R. We analyze the result by explaining that this inelasticity yields high tax revenue for the government. Finally, we provide the real-world context. Primary commodities, like crude oil or raw minerals, often lack close substitutes, forcing buyers to absorb the tax. To lock this in, we've synthesized these rules into a final matrix. For firms, inelastic goods mean higher prices lead to higher revenue. For governments, inelastic markets yield high tax revenue, while elastic markets alter behavior. For workers, inelastic derived demand allows higher wages. This matrix provides a clear roadmap for analyzing the responsiveness of different market players. Mastering these relationships allow you to predict how a price change ripples through the economy, from a small item shop to a national treasury.